evaluating these functions into actually constructing a piecewise function, writing one, and then also graphing one. So just as a reminder, when we're doing a piecewise function, again, it's just a bunch of different equations, linear equations that we know how to graph or how to write the equations for in that form of, right, mx plus b. So notice we've got the y-intercept and we've used our slope. Those are kind of the key points that we're going to use, as well as being able to restrict domain. So it's really important that we understand that these pieces can't overlap. So as we move forward, we're going to see that those pieces can connect, they can touch at certain points, but they can never overlap into each other's zones or domains. So it's going to require that we're kind of comfortable with restricting domains. So let's look at an application problem first and see if we can make sense of what a piecewise function would represent, and then we will create a few of them. So the first one says, a parking garage charges $3 for the first 2 hours that a car is parked. Okay, now we've seen situations like that, right? $3 where you go in, whether you park for 30 minutes or whether you're there for an hour and a half, they just charge kind of a flat rate for people that come in and use the parking garage. Then if you stay longer than that, the hourly fee is going to go up $2 per hour beyond that. Okay, so if we look at this, this is graphed off to the right. Notice that flat rate here, it's going to be $3 until you've been there longer than 2 hours. So this axis down here represents hours. After 2 hours, notice that slope is going up $2 per hour. So we've got a slope of 2 there. Okay, so again, this function it comes in 2 parts depending on how long you park your car. So if I'm making sense of this, right, this guy is time in hours on the x-axis, and then based off that I get cost or price in dollars that I'm going to have to pay. So part B says write a piecewise function p of h to represent the cost of parking a car in the garage for h number of hours. So we start by writing p of h. We then do equals. This is an equation, right? So we need an equal sign, and then we draw a brace. The brace represents a set of functions that create this particular function. So again, we start with the first piece. Now notice this first piece exists from 0 when x is 0 till x is 2. This first piece only lies within 0, meaning, right, you barely enter the parking garage, so I'm not going to include 0. But if we park anywhere from 0 up to, oops, I shouldn't use x, we're using h here, 0 hours up to 2 hours, I just have to pay $3. So again, if I'm going to write an equation, that's just actually no slope or 0 slope, and then I'm just flat rated at 3. So any value within there would give me a $3 cost. Notice then, if the number of hours is greater than 2, now I've been parked there more than 2 hours, suddenly the rate changes. So if you look at this line, again, we already talked about the slope here, but if we count the slope, it's up 2 over 1. So my slope here is going to be 2x for this piece. And we don't stop there, because notice this this line, if it kept going, that y-intercept would be down here at -1. We need that -1 because it represents where our actual line is. If you don't put anything there, you're telling me that line actually passes through the origin, which in this case it would not. So we need to add it, kind of like our absolute values with the vertical shifts and things, we need that there. So that right there would represent our piecewise function for this graph. Okay, you take it piece by piece, you build the equation like you know how, and then you do need to restrict it based on the domain of each piece. Let's look at a couple others. So if we look at example 3, notice that this one, if I look through this one, I'm going to draw in just a little line to kind of show you. This is like the left side barrier of this piece, and then there's this barrier here. So notice this first piece lies between -4 and -1, right? Here's this piece of the function that we're going to use. Now you can call this h of x, f of x, whatever you'd like to call it. Then we put an equal sign, And I know that I'm going to have at least 3 pieces, so I'm going to draw a brace big enough for me to fit 3 pieces. On the left, I then look at the slope of my line. So again, if I'm starting here at the edge, notice I have to go up, actually 5, and then run 3 to get the slope of that line. So that's 5 over 3x. Then if I'm still following that pattern, this may be something that's not as familiar to you, but if I have to go up 5 to go over 3 more, right? I want this y-intercept where it's going to cross, but it doesn't cross at exactly 3. Because we're going up 5 over 3, it's actually going to cross right here, which is 5/3 above where it was. So we're going to go up 5/3 over 1. Up 5/3 over 1 is how we would get there. So this is actually going to be 2 plus 5/3, which I'm going to write as an equation, or sorry, a fraction, 14/3. Okay, don't worry so much about that. You don't have fractional y-intercepts on your assignment. When we're looking at that now, again, this piece lies between -4 and -1. So when we restrict the domain, we say -4, and that was a closed circle, and there was a closed circle at -1. So that's the domain restriction for that piece. Then we look at the next piece, and I'm just going to use a different color just to highlight, and let's use purple. So notice it starts here at -1, and then this piece goes until +3. So this is a flat line at 2, so there's no slope there, it's just 2. And then again, this one lies between -1. Now I included -1 on the previous domain right here, so I'm not going to include it on the next one, even though they meet there and you could include it on either one. Then we're going to put x in the middle, and again, that domain ends, it looks like, with an open circle here when x is 3. So between -1 and 3, we've got another piece. And then our last piece is just this little guy down there at the bottom. And notice it's sandwiched between 3 and 4. So it's just a flat line at -2. And again, we're sandwiched between 3. And these are closed circles, so I'm going to include 3 and include 4. This right here would represent the piecewise function for this graph. Let me do one more of those. Again, the one you have in your guided notes book might be a little bit different. This is one that we kind of glued in. So, but essentially it's the same idea. So again, this one has 4 pieces. I'm going to move over just a little bit. So let's just go through, kind of walk through doing those same things. This one's 4 pieces, so I'm going to make that brace large. Again, you're going to kind of look at those barriers. So one of them is going to go right on the left side of the graph. Another one is sandwiched between what looks like -5 and -1. Then the next piece starts, and then it finishes at 3. So I know that 3 is one of those barrier lines, -1. This one's -5, hard to read. So that's where we're going to kind of build our functions from. So let's start with this first one. Again, in order to write its equation, we look for a slope. Notice this is going up 1 over 1, so it has a slope of 1x, or you don't have to write 1. Again, we need to say if it kept going with a slope of 1, where would it cross? Looks like it's going to cross up there at 8, so this is going to be +8. Okay. Again, I'm going to erase that so it's not in our way, but that's what we would be looking at. Then we restrict the domain. So remember this line, it looks like it's going from -5 and then everywhere left. So we would say when x is left or less than or equal to -5. And one way I can remember what way my sign should be going is if the arrow, right, is pointing this way, this little thing's pointing that way, that's less than, or that's the direction my arrow on my graph is going. Then we go to the next piece. So our next piece here has an open circle and then goes over here to an open circle. I hope that guy's open. Oh, but I made it look closed. So this guy is a flat line at -2, and this is when it's -5 open. So between -5 and -1. Then you have your next piece. So if we look at the next piece, again, this one's going from here at -1 and it's going down right? But it's sitting between -1 and 3. That's where it's sitting. So it looks like it has a slope of -1. It's going down 1. So we're going to say -1x or negative x. Its y-intercept is at -1, so we put -1. And then again, that piece is sandwiched between -1 with a closed circle and +3 also with a closed circle. Lastly, we would then look at this piece on the right-hand side. Notice it's an open circle and then it's going up. It also has a slope of 1 as it goes up. So we're going to say x. And then again, we want to continue it on to see where it would go and where it would cross the y-axis. So it looks like if we continued it down, okay, terrible drawing, sorry. It's going to cross right here at 1, 2, 3. So we are going to say +3. And again, this piece of our function is on the right side, so I'm going to put an arrow that way, right? It's greater than +3. And that would be our